Good morning, everybody. Today we're going to go over more trig functions or inverse trig functions and evaluating them, making sure that you're getting the correct answer, and just how to navigate through these questions, especially when you start plugging a trig function into an inverse trig function and the opposite way around. But just kind of getting used to this idea even more. So if you remember from yesterday, the inverse trig functions have limited domains and ranges, and we're restricting the domain of the original trig functions to get this. And the reason for it is so we can have a function in both, so we can have a one-to-one relationship. But because of this, it adds a little bit of wrinkle to these questions. You can't just pick whatever answer you want. There is a right and wrong answer. So you just have to make sure you're following the rules. So when we find the exact value of questions like these, where I'm taking a sine and inverse sine, whether this be inside or this be inside, you just have to check, does it fit within the range? Does it fit within the domain of each? And if it doesn't, sometimes you can still get an answer. It's just not necessarily going to be super easy. But pi over 8 is between negative pi over 2 and pi over 2. So thinking about this, pi over 8's over here. It's definitely not that large. But that's between these two things. So the y value is here. I'm going to be basically plugging in this y value into the inverse sine of this point. Which would get us back to pi over 8. It's still red from yesterday, so I'm going to switch that. No tricks here, just I'm taking the inverse of the original function. Think about like taking the inverse, if I do log of an exponential function with the same base. Those are inverses of each other, they undo each other. They'll undo each other anytime as long as they play nice and they're within negative pi over 2 to pi over 2. Switching this is even easier because sine doesn't have a restricted domain unless we're talking about inverse sine. So this is going to create an angle between negative pi over 2 and pi over 2. And that angle we can just call whatever, but basically we're coming up with something like this. This would give us a result of, so theta, I'm basically taking sine of theta in this situation. Sine of theta is going to give me 8 over 10 or 8 tenths. So this is still going to be 0.8. Whenever you have questions like this, it's just going to pop out whatever's here because it's going to give you an angle that gives you sine of, or a sine value of 0.8. So then when I plug in that angle to sine, it's just going to pop out the same thing. The tricks, the ones that you need to pay attention to mostly are situations like this, where I have more restrictions happening. But the restrictions here don't do anything to me, except the portions that you need to make sure you're following is, does it actually fit inside of this trig function, because I can't plug everything into inverse trigs. But same thing here, pi over 11 is between negative pi over 2 and pi over 2, so it's within the domain. Sine of inverse sine of pi over 11 is just going to be pi over 11. Okay? No tricks here. Eventually we're going to get into some that we just can't do, but for now it's just going to undo itself. Inverse cosine of pi over 12. Cosine of pi over 12 is again over here. This x value, if I plug in that x value into the inverse cosine, it's going to give me pi over 12 again. So this is pi over 12. Cosine of the inverse of negative pi over 4. So if we inverse cosine is going to be over here, where this x value is negative 0.4, And if I take cosine of this angle, it's going to give me the same x value. So again, situations like this, they're super quick because there's nothing really that's going to go wrong except for plugging a number that's outside of 0 to pi. Or sorry, between -1 and 1. Same idea. Check on your calculator, make sure that 5 pi over 16 is not bigger than 1. It's not, it's just under 1, but this is a little over 15, a little under 16. So 15 over 16 isn't going to be bigger than 1. No issues here, but you do want to check, is this actually within the domain of inverse cosine? But no tricks. Again, 5 pi over 16. This is B and C are going to be the same scenario where you're taking cosine of the inverse versus the inverse of cosine. These ones are the ones you have to be more careful about. With tangent, again, the restricted domain of tangent is -pi over 2 to pi over 2. We don't have a restriction on the range of tangent, right? It ranges from negative infinity to positive infinity. So the domain is unrestricted for inverse tan. Inverse tan of pi over 12. Nothing wrong here, pi over 12. This is the type that, again, we don't have to worry too much about. Should be just fine. And all of these are nice because you can check them on your calculator and it should give you the correct answer. Inverse tan of 0. Well, tan of 0 is 0. Inverse tan of 0 is 0. Okay. So all of these, nothing too tricky about it. You're just plugging it in and then reversing the process as long as there's nothing that's outside of the restricted domain, outside of the range, then you should be fine. In these cases, though, we're starting to get into some tricks, some things you need to pay attention to. With A, 5 pi over 8, I'm going to draw it down here. 5 pi over 8 is over here, ish. Okay. So sine of 5 pi over 8, it's going to be something positive. It's still above the x-axis, but when things are positive, and I take the inverse trig, it wants to put it into quadrant 1. These are not the same place, obviously. This is more 3 pi over 8. Right? It's going to give you the same y value, same height, just in a different spot. So does the inverse sine of 5 pi over 8 equal 5 pi over 8? No. It equals 3 pi over 8 because it's landing in a different position. Inverse trig functions have restricted ranges, so it's going to be giving us an angle between -pi over 2 and pi over 2. With questions like this, you just have to find the angle that corresponds to the same y value, but is within quadrant 4 and 1. Other than that, those are the tricks that you need to look for. This is one where we don't have to care too much about what's going on. Do need to be careful with this because I can't just plug everything into inverse trig functions. So just make sure it doesn't pass through the first function. And that is between -1 and 1. So we're good there. No issues. But careful. You do not plug angles into trig function or inverse trig functions. You plug them into trig functions. You plug ratios. You plug side ratios into inverse trig functions, and you get angles out of it. So -pi over 5 is talking about a triangle. So it's not going to affect the answer, but I do want to talk about that. So this is negative pi, and our hypotenuse is 5. We're working with a triangle like this. It's pretty nasty. This is like 25 minus pi squared, square root of that. So it's not a normal triangle. It's pretty gross, but the answer is pretty easy. Because negative pi over 5 is between negative 1 and 1, it's going to give me gross triangle with gross angle. Sine of gross angle gives me negative pi over 5. Okay, so yes, this is true. Just be careful when you're plugging in angles into or things that look like angles into inverse trig functions. Like this one. I'm plugging I'm plugging in something that looks like an angle into inverse cosine, but luckily this one doesn't really work because 2 pi is about 6. 6 divided by 3 is outside of the domain of inverse trig functions. So no, outside of domain. And you can actually check this one on your calculator pretty quickly because inverse trig of 2 pi over 3 is going to give you an error message or a syntax error or outside of the domain error. So just make sure you can always check these on your calculator. Just make sure you're using the correct mode when you're doing it. All right, cosine of 2 pi over 3 is going to be, well, I don't know why I keep doing it. Let's go a little more vertical. Okay, so 2 pi over 3 is here. Cosine of that is negative root 3 over 2. If I plug in negative root 3 over 2 into inverse cosine, it's going to come out to the same place. Because this is from 0 to pi, trig or inverse cosine has a range of 0 to pi. So it's within the range, and so this is just yes. On the next one, inverse tan of negative pi over 2. This one's undefined. I can't take inverse tan of an undefined value. So this is no, because this doesn't exist. I can't take tangent of negative pi over 2. Other than that, it seems like it would work. It should be fine, but it doesn't pass through the inside function, so it can't go through the second function if it doesn't go through the first function. For all that, this is going to be no. Inverse tan of 4 pi over 3. Again, this is side relationships. And the nice part about tangent is, or also inverse tan, is that it's unrestricted as far as it doesn't have to just be between negative 1 and 1. Tangent, if you remember, tangent looks like this with some vertical asymptotes at negative pi over 2 and pi over 2. But because the range of tangent is unrestricted, the domain of inverse tan is unrestricted. So there's no issues here as far as can I plug that in. If this was inverse cosine or inverse sine, then we'd have an issue. But tangent of inverse tan of 4 pi over 3, you just need to make sure is 4 pi over 3 between, actually no, sorry. Tangent of inverse tan should just pop out the same thing. So this is yes. This gives you a side. This is basically working with this triangle. And this triangle is actually possible. Possible triangles are in quadrant 1. Quadrant 1 is going to be working with the range and the domain of tangent, negative pi over 2 to pi over 2. it's going to be fine. So this is a yes. So other than that, you just have to work through these and make sure that they're matching up with it. I always draw a picture and just see, is it within the range of values that I'm used to seeing that are allowed. But really, most of these should look pretty simple as long as you're doing it with the same exact trig and inverse trig function. It can get a little trippy when you take inverse cosine of sine or inverse tan of cosine, things like that. But for the most part, they should be pretty quick because inverse functions undoes the other, and that's by design. So hope that made sense. These can go slow through these. They can be a little trippy, but if you have any questions, please stop by office hours and we can go through it. But until